Good afternoon, everyone. We're going to give it 1 minute as the attendee numbers. Give it a minute to stabilize, and then we will get going. Thank you all. All right, so good afternoon, everyone. Would like to welcome everyone to the third event of the A Summit series. Today's topic is automated vehicles in work zones. My name is Mahmoud Shahada, for those of you who don't know me, and I will be moderating today's event. I'd like to thank you all for taking the time out today to come to listen to our fantastic lineup of speakers. We're all very excited to have them here today. Just to note, this webinar will be recorded to be posted on the Pennsylvania AV Summit website. Before we begin, you will see that your microphone has been automatically muted to reduce background noise. Please feel free to use the chat function at any time to ask any questions you may have, and our chat moderators will voice your question during the question and answer section of today's webinar. As we begin today, a poll should appear on the side of your screen asking about what employment sector you are representing today. This poll will help both speakers and the audience know who here is represented on today's call. We'll leave the poll up for about a minute as we are starting, and after the time is up, we will share the results with everybody. As the poll is ongoing, we also would like to thank SAE for sponsoring the entire Summit Series webinar events. Just a little bit of background about the Summit Series. It is a series of virtual events created in the wake of the cancellation of the 2020 Pennsylvania AV Summit Conference. This event is the third of the series of webinars that will lead up to the 2021 Virtual Summit in October. There'll be roughly one per month with a focus on a specific topic that relates to automated vehicles. We have many fantastic topics and speakers lined up for our webinars, and we thank you for attending today and hope to see you at future events. So as you all can see, or hopefully can see on the side we do have a pretty good representation and pretty good cross section. We do have a number of state municipal government employees as well as consultants. But we do have some folks from nonprofits and other industries as well. So nice cross section, and are very happy and excited to have you all here today. So moving on, why don't we jump right into it? I'd like to again welcome our first presenters, April Wire from Maricopa County, Arizona, and Adam Carrion from Arizona DOT. April is with us today. She has worked in the ITS and traffic engineering field for 15 years. With Maricopa County, she is the Arterials Operations Program Manager and is responsible for the TMC operations for Maricopa County. She was involved in the development and deployment of Maricopa County's first smarter work zone implementation. April is a registered professional engineer in several states, including Arizona, and has a professional traffic operations engineer certification. Adam is also part of the operational traffic and safety group within the TISMO division at the Arizona Department of Transportation. There, he has developed his love for transportation over the past 17 years. Through that, he has personally championed the implementation of smart work zones within the department and is the state work zone operations engineer and the work zone safety and mobility champion. Adam is a member of a number of organizations advancing the cause, including 3 subcommittees with the Workzone data exchange, which we'll hear a little bit more about later on today. Adam is also published with TRB within his work in Maricopa County DOT on some of the information you'll hear today. Adam and I were talking about this earlier. He's happily married with 3 wonderful kids, and in his spare time spends his time coaching his kids in various sports: basketball, baseball, soccer, at various different levels. So with that, I think I'm turning this over to April. April, thank you.
All right, thank you for those kind words, and it's always a pleasure to be presenting with Adam. I enjoy working with him, and he's a great partner for our region. So I know we got a lot of slides to get through, so I'll go ahead and get started. So today, Adam and I are going to talk about the Aztec regional integration of local agency road closure and restriction data into the state 511 system. Next slide, please. And so just to give you a little bit of background about Maricopa County, it is a bit unique because, you know, as you go further west in the country, the counties get much, much larger. And so Maricopa County does encompass the entire Phoenix metropolitan area. It encompasses 9,200 square miles. It's the 4th largest county in the United States by population of about 4 million people. Our population is greater than 24 states. The county seat is Phoenix. We have 24 cities and towns and 5 Indian communities. Next slide. And so we focus on our work zone safety and mobility by kind of defining our goals. That is one thing that we like to do very early on in our projects as we move forward with initiatives. These highlight our 3 goals related to work zone safety and mobility. The 3 include integration and dissemination of work zone information to our roadway users to keep them informed of what's going on as far as, you know, approaching work zones and whatnot. Advanced work zone situational awareness through the smarter work zone deployment, you know, by the use of speed feedback signs, connected vehicle devices, and queue warning systems. Development of digital infrastructure to support connected and automated vehicles, because we know that's on the forefront and we want to keep that space engaged as we move forward. Next slide. And so this slide kind of shows where we've started with our regional work zone data initiative. You can see, I think some of the info on the slide got cut off, but you can see that we started our initiative in 2016. We deployed our first arterial smarter work zone pilot in our region. We tested a whole lot of different scenarios as far as work zone and put every device possible related to smart work zones out there because we wanted to understand what we were getting ourselves into and have a robust, you know, set of use cases for these different devices moving forward. As part of that project, we also did a connected vehicle work zone pilot as well with a couple of RSUs deployed out in the field, partnering with Swift Freight Transportation Company and DriveWise in-vehicle unit information system to get that work zone data into the freight truckers' hands so that as they approach work zones, they were able to see what was going on before they got there and, you know, choose their routes accordingly. As we moved forward with our regional work zone data initiatives, we participated in the FHWA's Everyday Counts initiative, focusing on smarter work zones and crowdsourcing information, and we continue to do that today. Next slide. So here's the rest of the slide. So you can see that we really started before our 2016 pilot in 2014 by trying to see what data was available for our region and trying to ingest that data as best we could. We quickly found out that there was a lot of different data streams coming in by the different local agencies. And one of the lessons learned was we wanted to be accepting of all kinds of data. And so I think I have a slide later on that kind of shows what kind of data we were ingesting from the different partner agencies as far as construction permitting data. Some of them were very robust in the sense that they had systems with APIs connected to, you know, their GIS software that would push that data to us, and others were less sophisticated because they were just entering in their information into an Excel sheet and emailing it to us. So it was a lot of manual work on our traffic management center to get that entered into our system so that it could be shared with our traveling public. Next slide. And so as we talk about our work in the Workzone space, we started working with a lot of our partner agencies through our Aztec platform. Our Aztec platform really brings together about 27 partners, including the local agencies, cities, towns, Indian communities, universities, public safety, and transit community all together so that we could really focus on traffic operations and maintenance and moving ITS deployments forward. And so one of the projects that we came together and went for was for the Workzone Data Exchange specification and deployment of that structure to have a data feed that was ingestible by third parties. And so here are the listed partner agencies that we work with. We also work with our MPO, MAG, Maricopa Association of Government, that helps with our planning, our state agency, ADOT, that Adam is from, and Maricopa County as well. Next slide. And so this slide shows all the different permitting feeds that we were able to ingest for our Workzone data framework. And so you can see here that we had some agencies sending in Gmail emails. We had some with APIs that fed in. We had web services, but all of them ended up going into our Amazon Web Services cloud area and then processed through our regional archive data system, which houses a lot of our regional transportation data, and then processed and pushed to our Arizona statewide 511 website, and also a feed was created for WZDX information for third parties to ingest. Next slide. And so in that WZDX framework, really pushed by USDOT and FHWA, here are some of the fields that you'll find. You can see that it goes from basic information from, where the location is, start date, end date, how many lanes are being dropped, or the status of the lanes, if they're open or closed, and any other relevant information that, drivers might need as they enter into a work zone. Next slide. And so this slide kind of just shows the idea of our information generators consists from, our construction department getting those traffic control plans, and our TMC staff manually entering them into systems, and then also data coming from our smarter work zones through their DMS boards, the travel times coming from that system as well, and then camera feeds. And so the idea is to be able to push that information through our WZDX platform into freight vehicles and automated vehicles for our pilot. Next slide. And so this slide shows the integration of our architecture for our Workzone pilot project. And so with this one, we're really focusing on the connected vehicle applications. You can see here we had I think there was 2 roadside units that were deployed. We utilized dedicated short-range communication radios out in the field onto temporarily installed trailers. So the data was, a geofence was created, and once the freight vehicle, the Swift vehicle, drove through that geofence area, then a message was pushed through the DriveWise server and displayed on their in-vehicle units. All of that data was processed through our regional archive data system and then also broadcasted to our RSUs into the vehicles. Next slide. And so this kind of gives you an idea of what was displayed in the vehicle. It's a very basic display that DriveWise supplied through our partners of Swift. It would just pop up messages that we would push out through our WZDX feed as the vehicles entered into the work zone. Next slide. And so some of the goals and objectives related to our connected vehicle work zone initiative was really the development and deploy a work zone warning and alert system utilizing VSRC connected vehicle technology, and then also connecting those systems with variable speed limit signs, queue warnings, lane closure warnings, and also other messages that can be pushed to the vehicles. Next slide. And so this is the concept for that. Here you'll see the 2 RSU units out there again. We had 4 information areas. The first area being the informing drivers of what's coming up ahead. The aware area, more messages pushed out. The alert, and then the warn area. So as the freight vehicle travels through those 4 geofenced areas, they get different messages and different advisory alerts. As they traverse that work zone, they would get messages related to travel time, and compare the travel time through the work zone versus the travel time taking an alternate route. We got a lot of good feedback on that. It was a very short section, but at the same time, a large project to traverse. Next slide. Okay, so this is the prototype of the trailer. You can see it was a very large trailer, lots of solar panels, and then an enclosure and a CCTV camera on a telescoping pole. Next slide. So there are a lot of different scenarios that we try to test. One question always being, is the data collection required for each change in the work zone, necessary? And how often do we need that information? Next slide. And so here's another question in use case as far as like what lane configurations are there. So as we went through and set up these, we would always have to ask ourselves, are these use cases applicable and how do we adjust to them? Next slide. And then third question, is it a bidirectional lane or shared? Next slide. And then I'll pass it over to Adam. I know we're short on time, so.
Thanks, April. Yeah, I'll just jump right into it. So, I come at this from a work zone, actually more of a construction background, and I got first introduced to all of this through our work zone safety mobility program at ADOT. It's a federal requirement for the state DOTs. So, this goes just kind of back to the backbone of how this started, at least on my end, and how a lot of states are getting into it, is the requirement for data. We want to make our work zones safer. So how do we do that? You have to collect data on them and then develop performance measures. So the goal of collecting data has always been a requirement for, I believe, the last 14 years. More recently now into the AV space, this is just an example. I don't mean to pick on Tesla by any means, and this is a incident management versus a work zone, but traffic and incident management is, a type of work zone. And the technologies, the cars we have, the autopilots now, don't respond well when there are changes in the roadway, especially when it comes to geometry, but just other things like speed and just anything out of the ordinary. Is a challenge. So, how do we then go forward? I've started presenting, and I would talk about the benefits of safety of work zones by doing smart work zones, by having data collected in your work zones. And a follow-on point for me to my initial audiences was, and AVs will need the data. They'll need it at the very least to have a redundant system on what their cameras are picking up to verify what they're seeing. And so now it's almost coming around full circle where now I'm doing a lot more AV type presentations and circling back to the safety aspect. So the DOTs are collecting the data, they have access to the data, and so we need to be pushing it out. I'll just go ahead and keep going. So a lot of the first couple bullet points there are old sources of data, a lot of manual entry, a lot of waiting or months to years even to get all the data together. And then we started getting into the third parties of the INREX type data. But again, the crowdsourcing does have limitations. And so now we're finding other ways to get real-time data. That's either from the vehicle itself. That's actually social media. There's been a few studies where social media, Twitter accounts will notice an incident several minutes before the TOC is notified. So, or that's our traffic operations center. So there's a lot of new places for us to get data. This is the space of the AV data. I mean, there are just hundreds of players in it, and they're all collecting data. This is going over smart work zone systems. I don't need to get into each one of these. These are systems, safety systems that are real time using automated systems that connect to usually message boards to communicate messages to the driver. So we're still working through the manual, the ability of the driver to see the sign, but it is real-time data collection. So we are collecting, not all DOTs, but a lot of us are collecting data. And as far as Arizona, we're not doing a whole lot with it. It doesn't actually go to our 511 yet. We're working on those things, but we're collecting a lot of data. We've got more sources coming. This stuff we're coming in very soon. The error board is a sign of whenever we close a lane, that's the first thing you see. So these are additional sensors that are coming through. So again, some states or cities or municipalities already use these systems, and then we're just trying to kind of almost keep up, because my thought is eventually smart devices will just become devices as they are now. Everything, every cone, every barricade should have some kind of device on it transmitting data. And that goes to show, to temporary signals, signs themselves. The technology's out there, it's not widely used, but literally marking every single sign transfers favors. The worker presence is a whole subcommittee within the Workzone Data Exchange that it's got a tough challenge on how to identify to a vehicle that workers are present in the roadway. It's not 5 years, we're talking very soon. These things will, and some of these things are already out there, just not widely adopted. This was just a resource on work zones if you want to learn more, or depending on who you're with, don't need to reinvent the wheel. So ADOT has a pretty decent web page for resources. The smart work zones have been around for coming up to, I think, 2 decades. And only recently, though, has the cost just come down to a point where there's no reason not to be doing it. It's a very minimal, usually adding a smart work zone to an overall construction project is 1% to 2% of the total costs. So, and that can be sometimes offset by, a lot of times you use a lot of law enforcement officers to help reduce speed. So these systems can kind of offset those costs and sometimes be a cost savings. There's also federal programs to help keep the costs down to the state itself by increasing federal share. That's through our Everyday Accounts initiatives. So that's a big push for why it's becoming widely available now. And then I know it's going to probably be talked about later, but all of this data, right now is still kind of not formatted to work together. And the Workzone Data Exchange is our effort to do that. So that's all we have. I think we're taking questions at the end. Thank you.
Adam, thank you very much. April, thank you very much for that presentation. A lot of good information and great start to today's discussion. So thank you both. Let's switch gears now. As Adam mentioned, we are going to be taking questions after the presentation. So, but if you do have any questions, I see a couple people have started to enter them in the Q&A functionality in this webinar. Please do so. In the meantime, I'd like to introduce Mike Mullenauer. Dr. Mullenauer is the director of the Division of Technology and Implementation, at the Virginia Tech Transportation Institute. In this role, he leads a team of researchers and engineers that help customers conduct early stage development and evaluation of connected and automated vehicle systems. Most recently, Dr. Mullenauer is leading VTTI's efforts with partnering with Virginia DOT to help develop the Virginia Connected Corridor through the development of V2I and V2X infrastructure. a cloud computing environment, and a variety of mobile connected vehicle applications. And a lot of that work has focused on workzone safety and interactions between automated vehicles and public safety professionals. So with that, Dr. Mullenauer, the stage is yours, sir.
Appreciate it. Thank you for the introduction. Just to make sure, verify that you can hear me okay.
You are good.
Okay, thank you. All right, first I'll start off with a plug for the home office. I am from the Virginia Tech Transportation Institute. We are, by most measures, the largest transportation institute in the United States, and we have very much a safety focus, and we've impacted policy and helped, I guess, develop and evaluate technology at all levels of the transportation system, and have had a pretty heavy impact, like I said, on transportation policy in general. We are a fairly large organization now, around 500 employees. Many of those are full-time and engineers, and we do a lot of technology development as well as technology evaluation in real operational environments. We've had a great opportunity to work with the Virginia DOT, and I want to acknowledge their support through almost every aspect of what we do when it comes to work zone safety and the development of technologies around that area. And we continue to work with them moving forward on many of these projects. In terms of automated vehicles and with the challenges that work zones present for them, I mean, obviously, they're very unconventional at times in layout. It means that the flow of traffic might be changed. So whatever was in the mapping system is not necessarily valid from the time the work zone is active until it's, I guess, removed. And the level of standardization of any of the layouts, and while there is standardization on some of the larger projects, there can be quite a bit of variety that's difficult to, I guess, compartmentalize down into just a small number of categories that would be easier for an AV to understand. And so they have to have some ability to interpret themselves. But as we believe, a connected automated vehicle, we think is safer than just an automated vehicle using nothing but its own sensors. And so, having data to support, from the infrastructure owner operators to support what the vehicle is seeing with its own sensors is also very valuable and really helps with beyond sensor horizon trip planning kinds of activity. So, we're out there to try to support improving the data that can be made available and making that process flow a little bit easier and more real time and more accurate so that it can be used effectively. See, when we think about the different data elements that are useful around a work zone, I mean, just kind of listed out a few of them here, but really we're talking about a lot more precision than what has been known before, down to the locations of individual channelizing devices, where tapers begin and end, where the activity areas and the types of hazards that are there, including and also reduced speed areas also. And so these are the types of elements that we're trying to build into our, I guess, data production and data handling processes. Some of those recent initiatives, then we have a couple that I'm going to talk to you about here fairly quickly. Each one of these could probably be a presentation, but I think I'll just try to very much touch lightly on them and then talk about a demonstration program that we have at the very end. So the first is called the Workzone Builder application. So this is a tablet-based application that VDOT has funded us to develop, where a workzone designer can tap out an activity area, choose an MUTCD or work area protection manual template, and apply it to that area, and it will automatically place the signs and the tapers and the cones and the arrow boards and everything that goes into that work zone onto the map. And it also creates the underlying data structure that then gets, I guess, forwarded into our VCC, Virginia Connected Corridor cloud computing environment. Within that environment, then, as the work zone gets migrated through a set of statuses, the work zone data becomes, I guess, active, if you will, and gets posted. So we automatically generate traveler information messages, which is kind of the current standard for, I guess, identifying where work zone features are. We automatically generate those and post them to our Virginia Connected Corridor cloud computing system, and they can be accessed either through connected vehicles that are talking to our system through roadside units or through a public API. So other outside users, third-party application developers can access them from there as well. In the future, we will be putting data directly into Virginia's Workzone Data Exchange. They were one of the winners of the grants, so we're looking forward to that activity being finished so that we can begin keeping data up to date with that Workzone data exchange as well. There's also a feature within that tool, the Workzone Builder tool, that allows someone who is operating at the Workzone to, I guess, effectively hit a button on the display to take the Workzone active and show worker presence as well, so when they're there. Another component of the smart, I guess, data system that we're trying to use to provide Workzone data to automated vehicles is a smart vest. This is a wearable that, when combined with the base station, can be used at a Workzone to localize the individual workers to a fairly high degree of accuracy. It is RTK corrected GPS that's built in, and there's an IMU as well. And so the way we use this, the vest wearers effectively communicate with a base station over a Zigbee network, and we also have a smart cone device, so individual features within the Workzone can be noted using a smart cone device as well. They all talk to the base station. The base station has an RSU that then communicates out to passing motorists if they're equipped with a device to be able to receive those communications. But we also push it into the cloud so that, again, API access is available to be able to pull that data in real time to get where the workers are. Usually that data is consolidated down, and we're providing both presence information when the workers are there and when they're not, but also some geofence boundary information to them as well. And they get messages, the wearers get messages either through speakers or through the lights that are on the vest itself, or we have vibrotactors on the belt component that's internal that you can't see here, but there is a belt piece of it that goes around the waist where you can give directional signals to the user. To give you a sense for what this works, how this works. So a geofence boundary has been created between these two barrels. The worker gets one initial warning, which is less, I guess, obtrusive, and then as they exceed the boundary, it's a much more obtrusive warning to let them know that they're stepping out of what is to be considered a safe zone, of a safe area of the work zone. We also have, I guess, collision detection algorithms. Again, if we have equipped vehicles driving through the work zone and they're on a collision course with that vest wearer at a low time to collision or enough time to get them to be able to have a chance to move out of the way, we would give them a notification so that they would look up and become aware of the potential threat. In looking at the accuracy of the system, it's fairly important so that we don't get a lot of false alarms or false positives. This is maybe a 20 by 20 meter section that was set up between the yellow vertices that you see kind of on the corners. We had a wearer wander around for quite some time, and we captured the different classifications for their position at each of this areas. And so the green area inside would represent what would be called like a safe area. A blue area, if the wearer entered the blue area, they would get a notification that they're getting close to the boundary. And then when they're in red, they would be exceeding the boundary. So it's a fairly accurate, very low latency way to let a worker know when they're getting close to a dangerous area. Another component also that we've been working with as of late is, I mentioned before, the base station development. And what this does, again, that's the unit that you would put out with, in conjunction with the vests or the smart cone devices. They're all communicating data to the base station. It is broadcasting the results of that data aggregation to vehicles that are passing by, but also pushing it into the cloud over a normal 4G communication link. And then others can tap into that data again through the public API if necessary. But that this is all effectively being productized at the moment, meaning that we're going through a process of doing the cost reduction and boiling it down from what was a bit more of a science experiment down into something that's very ruggedized and ready to deploy in typical work zone environments. And that includes both the vest and the base station component. And the RSUs, of course, are off-the-shelf RSU equipment that we've integrated into the system. We've done a recent demonstration program working with Audi, Qualcomm, American Tower, and the Virginia DOT to demonstrate this both on our Smart Road facility down in Blacksburg, that's our test track, as well as on public roads. And to support that, we integrated, I guess, the OBU component or the receiver within the vehicle and developed the software to manage the flow of data there as well. So it receives the messages about where we call them a vulnerable road user or the vest wearer is, and then provides details to the driver about when they're approaching and when a collision may be imminent. We will be doing additional demonstrations in the Northern Virginia area probably within the next month. We had some delays due to COVID that pushed us off a little bit, but since things are opening up, we're now rescheduled to do that. And you probably will see some press announcements about that in the future when we get that activity done. So when we think, about the data underneath and how it could or should be used, this is just an example of a work zone, and let's say that it's been designed using our work zone builder tool. From that work zone builder data definition, we can automatically generate the work zone safe areas, or areas where the workers can be allowed to roam or work when they would not be getting information about being in a more dangerous area. And those are what's signified in blue. And the work, through that worker, through that, as they approach the live edges of that work zone, they would start to get messages from the vest about when they're getting close. And again, as a vehicle also approaches, if the vehicle is on a collision course and they're not, following the rules, meaning maybe not reducing their speed and or merging at an effective pace for that work zone, messages could be given to the workers to give a heads up at least to look to see where the danger might be coming from. As the work zone is activated, we also, as I mentioned, post these traveler information messages. So again, as it goes active, if this vehicle has the appropriate equipment to be able to receive that message, they would receive it on the instrumentation cluster. And so they'll be giving information, and some of these are likely conditional, right? So we would give the right lane ends, merge left, and reduce speed to 45, but we would only give those messages if they're not already complying with that. This is an example of what it looked like in the real dash and the real types of messages that we used as they went through this testing process on our Virginia Smart Roads test track at our facility in Blacksburg. Okay, so those are a lot of the components that we have developed to be able to, kind of or to report data and make it available at a higher level of accuracy for automated driving systems. We were fortunate enough last year to have received two of the Federal Highway Administration ADS demonstration grants that were awarded, and that was excellent for our organization. One of those is involved in trucking fleet ConOps and automated trucking systems, and that's in a different group within our organization. My team developed the concept around how do we demonstrate safe operations of automated driving systems with public safety and maintenance, facilities or workers on the side of the road. So we're looking at fire, EMS, police, as well as work zones and safety service patrol, and even towing operations as well. And so our concept really is to come up with, we're building a level 4 automated driving system, and we are working with the community to understand what the interactions are that are often, seen with human drivers, and trying to understand how we're going to, support those same things with automated vehicles so that the communication link is not broken between those that are operating close to the road in dangerous scenarios, and looking at how both the vehicle will communicate to the workers and how the workers will communicate to the vehicle as well. We have a lot of partners on this project. Transurban operates the express lanes up in Northern Virginia. That's where we'll be conducting many of the demonstrations. It's a really nice environment because it's a reversible road, and they shut it down for about an hour and a half, 2 hours in the middle of each day, which gives us a great chance to test everything when there's no traffic to interact with, to worry about from a safety perspective. And they are a good infrastructure owner operator partner, and we'll be operating many of the infrastructure side systems for the project. Our Global Center for Automated Performance and Simulation will be taking the data that we collect as we operate these demonstrations and turning it into simulations and scenarios that will be distributed out to a variety of different ADS developers and communities who want to either use it for training or use it to improve ADS algorithm development. Regardless of how they want to use it, all that data will be made available for years after the program is complete. We're working, of course, with OEM partners as well. So we have the Collision Avoidance Metrics Partnership, and a number of the OEM partners are listed there that are involved. They're helping us define the scenarios that they feel are difficult to achieve with today's existing technological solutions. And we're helping to figure out, what the interaction looks like, what's the task analysis that, for what the worker needs to accomplish, and then how should the vehicle respond in a variety of scenarios. And we have our public safety professionals that are we're working with as well. So we're doing a lot of focus group kinds of activities, getting some early feedback on the technologies that are being chosen, both from a perspective of practicality, but also how useful they think it would be, and how can we tweak it to make it a better, I guess, a more efficient system. So a couple of things that are being developed as part of that program. There's a concept called an operational design domain. This is what an automated vehicle is effectively built to be able to handle. So it might be that my operational design domain as an automated vehicle is freeways with limited access in good weather and maybe no work zones. Or it might be that I can handle just about everything. One thing that we're trying to develop is to get information from the infrastructure owner operators who have a lot of this information already and have it in fairly, I guess, high quality, is to get that into a tool, and then from the tool through a set of messages out to the automated driving system so that they can use it to understand where they can operate and still maintain their, I guess, operational design domain standard. And so that data is being packaged, it's getting put into segments, if you will, and then being transferred out to the vehicles to consume so that they can understand where they can operate. And it might be that it's not where they can operate, it might be that they just operate with a different set of parameters. So, perhaps they keep a longer headway if the visibility is lower in a particular area. And so we're working on how do we source all of this data in real time? How do we get it into a new message set package, get it out to the vehicles so that it can be consumed? And that's kind of one of the bigger efforts that we have. And another component of that is we want to be able to allow the ADS to query that information when it's not actually on the roadway. So maybe it's sitting in the garage and somebody's doing trip planning and they want to understand if they can get downtown, if you will, right, through a particular corridor, and they would be able to pull that information, before they ever get on the road. So it does help improve the digital horizon effectively for that vehicle so that they can look out further ahead and do better planning for what they're about to experience. I mentioned before that we're working with our public safety professionals to understand how they interact with vehicles today so that we can apply some of those same rules to the ADS. And we've created a variety of scenarios that we think are very, very challenging. Even something as simple as a traffic stop, you can think, might be really challenging, or not so challenging, but if there's no driver to respond to the officer, and if there was no communication between the vehicle and the officer, how does that officer know that they're going to be interacting safely? So we're trying to develop solutions to communicate with the officer, to exchange data with the officer, but then also have the officer have the ability to release that vehicle when the stop is over. And so that's just an example, but there are a variety of different scenarios that we'll be working through, including work zones and flagging operations, and how do we handle things like hand gestures, and how do we, I guess, give everybody the comfortability that these things will be done in a safe manner. I mentioned we're building up the vehicle. We're doing that using one of our test vehicles right now. We will be purchasing a dedicated vehicle for this here shortly, and we're using the NVIDIA Hyperion and Drive software suites. Really fun exercise for our team to be able to get our hands on these tools and develop them. Our vehicle is currently operating fully autonomously on our test track facility, and so it can drive itself to wherever it needs to go on that facility and do it safely, including both lateral and longitudinal control and response to objects. And we will be now, I guess where we're at in the status on that is that we're starting to develop some of the specific technical solutions that will be bolted onto that vehicle, if you will, to support the interactions with the public safety and work zone operations. So we're going to be designing and conducting demonstrations. Most of this will occur on, just south of the Pentagon on I-395, I-95. At the middle to end of next summer is kind of our target date. We've done other demonstrations of automated vehicles along that same corridor, and it's a really nice area because we can get people from DC, the lawmakers, DOT professionals, and there's a fairly good access for folks who want to come out and experience it live. We'll also be doing some of them maybe that aren't as safe. We'll be conducting those on our test track facility where we can control the conditions and interaction with public traffic a little bit better. And so there'll be a wide variety of focus group sessions trying to elicit feedback from those who are out witnessing the program and riding along. And I mentioned before, we'll be processing this data once we are collecting all aspects of the data. So almost everything that's out there will be instrumented at some level for, with devices to position them. There'll be sensors, cameras, things like that to be able to capture this data. That will all be made available through a public data portal in the future to allow others to use it for the maximum benefit. So we look forward to completing that program, and many of the technologies that you see that we've started and started working with and developing with VDOT will be incorporated into that program, and hopefully fully functional and maybe at a more production level by the end of next summer. So that's what I had to tell you about today. Thank you. And I guess it sounds like we're waiting to take questions to the end.
Yep. Thank you, Dr. Mullenauer. I appreciate all the wonderful information that you provided today. Want to quickly move to our next speaker, Todd Peterson with the Federal Highway Office of Transportation Operations. Todd has been with the Workzone management team at Federal Highways Office of Operations since 2013, has specialized in ITS and data for Workzone management. He created and currently leads the Workzone Data Initiative, which USDOT is working with federal, state, and industry stakeholders towards real-time development of data for non-recurring events affecting transportation system management and operations. Todd was once upon a time one of the best softball players I've ever seen, as we played on a corporate softball team together years ago, and very excited to have him here. So Todd, take it away.
All right, thanks, Mahmood. Just sweet lies about my softball prowess. I'm not quite sure how to respond to that, but let me go ahead and get this queued up. Mahmood, am I presenting now?
You are. You do have an Outlook thing. There you go.
Perfect. There we go. All right. So this being National Workzone Awareness Week, in the spirit of that, I'm going to talk a little bit about the Workzone Data Initiative and how that really benefits the state of the practice in terms of providing this situational awareness of Workzone activity, and as it's topically relevant to AVs being the topic of the day. This is maybe not necessarily directly referencing AVs, but what we're going to talk about, what I want to talk about is this background digital infrastructure that's necessary to support the eventual rollout of AV and ADS technology and a lot of the other supporting technologies going along with that. So keeping that in mind, background of this effort, really arise from an awareness that transportation management, specifically pertaining to work zones, is highly dependent on good data. And as professionals with responsibility for transportation operations, we need more than just the data. Even what we need is the actionable information. So work zones are one of those areas where, as we try to pay attention to how they affect operations so that we can respond to it, and develop information describing that activity, it becomes pretty clear that work zones are a data sharing challenge. The work zones themselves, if you're looking at how to describe those in a data space, work zones are highly variable. They vary widely in scope, from the cherry picker on the side of the road with the guy waving around traffic to long multi-phase long-term construction sites. So developing a common specification or a common language for referring to work zone activity is a challenge. Those work zones are subject to rapid change. We even have mobile work zones that are dynamic. They're moving. So it's not always as simple as taking a pin on the map and saying, here's your work zone. Finally, the question of stakeholders. There lots of different areas that work zone information is necessary for, both within the agency itself. You're talking about work zone information at various points along the line, touching a lot of different teams. And then when we start talking about external parties and the public, there's the broad stakeholder interest in work zone activity and how we represent it. Currently, there's no national standard for how we talk about work zones in a digital space, and that's a big challenge. And that's one of the things we wanted to try to address with the Workzone Data Initiative by establishing a framework that describes all the areas in which Workzone event data is being used and is needed, and try to come up with a common open specification for how that can be, how we can facilitate that communication. Doing this, we kind of started this with the idea that this was serving our analytical purposes, getting a better feeling of how work zones, the exposure to the public of work zones is. But, very quickly it became apparent that this type of information is critical for emerging use cases like AVs, like connected vehicles, providing that communication to the public about what's going on, where our work zones are, and providing that situational awareness. So, work zone events, when we talk about what is work zone event data, really you can think about it from the standpoint of the work zone project delivery lifecycle and how that applies to work zones. At some point, your work zones are a planned event. The information's maybe a little bit of an estimate, a little bit, variable up in time until that first cone goes down, at which point that becomes that's real-time information we're dealing with. That's information that needs to be conveyed to the public. It's prescient. It's useful for both management and traveler information. And then when that last cone comes up, that information has enduring value in analytics, performance measurement, a lot of information going forward. So the definition of what is work zone event data, it has to take that life cycle into account. Similarly, we mentioned stakeholders. There's a broad range of stakeholders that are using this data for different purposes, and they each have kind of their own priorities from the standpoint of what's important to them for what they're doing. So in considering a framework for work zone event data and a common specification to go along with it, we had to keep that diversity of the stakeholder audience in mind, and what information needs to be part of that specification, and what are the potential uses for it throughout that project delivery life cycle. So as we tried to document an actual framework for work zone event data, we wanted to approach it with the knowledge of those uses and the stakeholders in mind, with a sensitivity towards how is this information currently being utilized. So the framework we developed looks at these individual use cases, individual data flows, and tried to map it, remap some of these processes around the notion of what we're called here the work zone event data warehouse. But I want to be real clear on what we're talking about here. This isn't a prescriptive idea of some specific IT architecture that's being referenced. Think about this very conceptually in terms of a centralized point of accessibility to common work zone event data and a common specification. So as you look at this, you can see that there are aspects of this architecture that feed into that warehouse, and there's others that draw from it. Some of these processes go both ways. So that's really this diagram here is a simplified version of the broader architecture that looks at the kind of the key information flows for those various stages of the project delivery life cycle. Planning has its both contributing to and drawing from the warehouse, as do the construction activities. The construction interfaces, there's a lot of the feeding from the warehouse, to and from ITS devices, and then finally for the performance analysis here. So this encapsulates the entire work zone lifecycle with that idea of centralized data storage and management to accessible work zone data. So again, this is a simplified idea of what that architecture looks like. But the next slide is going to broaden this out. I'm going to show you the whole architecture here. I'm not going to go through this bit by bit. I know this is a lot to digest in one slide, but I want to show this for two reasons. One, if you actually sit down and follow this, you can follow the architecture to show how data, you read it from left to right, you can see how data enters the system, and then coming out on the other side, there's you see the various use cases for how the data is being utilized. And this architecture is, again, these are not new processes that we're documenting here. These are existing, accepted, well-established processes by current agencies managing work zone activity and work zone operations. So this is, you could look through this. There's nothing on this list that that your agency isn't already doing, probably, but it is a remapping of those ideas around how all that feeds from, how that utilizes a centralized work zone event data warehouse. So this architecture is a good reference point for agencies that are trying to understand how what they do today can be adapted into a work zone data friendly process. Prior presentations for Arizona and VDOT, but Mike and Adam and April, they're all we've worked with them closely in helping adapt this framework to what they're doing. So there's kind of a proof of concept there, and being able to adapt this to specific agency processes. So this is kind of the best idea we have at this point of being able to encapsulate everything in one graphic. It's a lot to take in, but it's the framework document, which I'll present at the end, does go into each of these information flows in some measure of detail. So when that publication is made available, it'll be easier to understand some of that. So the building on kind of this core concept of a work zone data system architecture and a common data specification via the work zone data exchange, are looking forward to kicking off the Work Zone Data Exchange demonstration grants. The 13 agencies have been selected for that, and who are highlighted here. And each of these agencies have basically taken that architecture on the previous page and have elected to participate in these grants by deploying a Work Zone Data Exchange feed in the service of one or more of those information flows that's documented in that system architecture. So that's what we'll be looking at. That there'll be a lot of outreach. There'll be opportunities for peer exchange, not just with the grant participants, but also with other agencies that are working independently with their own work zone data system architectures. So that's coming up, and we're anxious to kick those off here in the near future. Finally, I wanted to make you aware of several resources that describe federal efforts on the Work Zone Data Initiative that will be published in the near future. These three are listed here. There will be more information forthcoming when those are actually published, and we'll probably have a follow-up webinar ourselves to make that notification when they come out. So with that wraps it up for my presentation, and I guess with that, I'll be handing it off to Vijay.
Todd, thank you very much for that presentation. We very much appreciate it. And as Todd mentioned, our next speaker will be Vijay Vera Rajan. Vijay is a senior project manager with emerging mobility projects with HNTB here in Pennsylvania. He is a certified professional engineer with more than 20 years of transportation engineering and ITS experience. That experience includes ITS and emerging technologies planning and research, design, implementation, integration, construction engineering, inspection, and project management. He is currently the consultant project manager for PennDOT's ADS project for safe integration of automated vehicles into work zones, which he will be talking about here today. So Vijay, take it away, my friend.
All right. Hey, good afternoon, everyone. Happy Thursday. Just one day from Friday. Looking forward to it. We hear a lot about work zones. I was counting. There was more than 100 times in which the word work zone was mentioned, rightfully so. So I'm going to add to that and add few more number of times of mentioning work zones. So with that, what I want to do today is, as Mahmood in the introduction talked about, Pennsylvania, specifically PennDOT, won a ADS grant for seeing how we could safely integrate automated vehicles in work zones. And that's what we're going to talk about today. So here's the agenda for today. I'll quickly touch upon the ADS grant and the challenges that we're trying to solve as part of the grant, and talk about what our project is about and who our project team members are and what are the next steps. So with that, as Mike touched upon, there was 60 million demonstration grant available provided by US DOT to see how they could um, remove any obstacles for integrating AVs in the future. Okay, and the main goal of that grant are threefold. One is to safely test the integration of the ADS, and number two is collect significant amount of data, and not only collect but share. Not only share, but share in real time and also in non-real time. And then the third goal is to collaborate with different types of partners, public, private, local, state governments, all kinds of partners, so that we could leverage the collective expertise, ingenuity, and knowledge of multiple stakeholders. And there were 73 applicants for the ADS grant, and 8 were awarded finally, and PennDOT got $8.4 million. If I may say so, that we got the highest among all the 8 awardees. So what are we trying to solve as part of the grant? The left quote from Wired magazine in 2017 sums up the challenges that self-driving pioneers like Google and Delphi cite construction as a common reason their human engineers take control of the wheel while testing. So which is what we were trying to investigate. And you hear a little bit from Mike on how they are using their grant to investigate a different aspect of work zones and how to use L4 ADS interaction with public services. We took a different approach, but for the same work zones, which we'll talk about in the next slide. So why we chose work zone? Very quickly, Mike talked about a whole lot of reasons. We chose the work zone for the same reasons. Challenging environment, unfamiliar conditions, different set of visual clues, conflicting pavement markings, and different lighting conditions and safety of workers, and many, many more. So, and that's why Pennsylvania picked work zone as a topic to investigate and see how we could safely integrate automated vehicles in work zones. So we took a 3-legged approach: connectivity, machine visioning, and HD mapping. So let me talk about each of those real quick. So connectivity. Now, can we improve the AV operations in work zones if we can have the connectivity between the vehicle and the work zone artifacts like drums, cones, and workers? Will that make the AV operations safer? The second legs tool we took is machine visioning, what we call machine visioning. So what we are trying to investigate as part of that is, if we have different kind of coding on the pavements or on the work zone artifacts like drums and cones or on the workers, will the AV be able to see, in quotes, those artifacts better so that they could navigate the AV zone better? And the third legs tool we are looking at is HD mapping. Can we generate the map of the work zone and have it in a specific format and disseminate that information to the approaching vehicles in real time so that they know how the work zone is going to look like, what are they going to encounter, and decide if they can encounter those kind of work zones and how they can safely navigate in that situation. So the vision for this project is to enable AVs to safely operate in work zone without human intervention. And the mission is to obviously reduce the fatalities and increase mobility for all road users in work zones. And goals, when we're coming up with the goals, we were talking about different things, but we narrowed down to say that, can AVs perform the best? Is that the goal of this project? No, what we're trying to achieve is, can the AVs safely navigate the work zone in par with non-distracted human-operated vehicles within the work zone. So that's our goal, to see how we can make the AVs operate in par. And then objective is to see if improving the connectivity, visibility, providing HD mapping, and disseminating the map information, we can improve the AV operations in work zones. So we just started on the project. We got the kickoff early this year, around January, and we are literally starting this project now as we speak. But the approach we are taking is, in terms of how we are going to accomplish the goals, is that we are taking a three-phased approach. During phase one, we are going to plan for the deployment and testing. And during phase two, we are going to actually deploy and test whatever we have planned for. And finally, in phase three, we will evaluate how different things worked based on our project. The phase one planning, we are anticipating it will take us approximately 1 year to do it. And we have a total of 13 tasks. And you will see the V diagram. If you're in an ITS meeting, you got to see this V diagram. If not, you will not be, many ITS engineers will not be satisfied. So I want to make sure I make a lot of ITS engineers happy, so I threw it in there for you guys. So we are going to follow the systems engineering process, and during the planning phase, we will have a total of 13 tasks, starting from the project management, risk management, SIM, ConOps, requirements, architecture, through the deployment plan, operations and maintenance plan, data management, so on and so forth. And during phase two, which we'll talk in detail a little bit more, it has 4 tasks. Again, I'll talk a little bit more. And then phase three, we will do the evaluation of phase one and phase two, the deployment. All right, so the deployment phase two. How are we going to do the deployment and testing? We're going to do it in three phases. In the phase one, we are going to simulate the work zone scenario. And then in phase two, we are going to do some closed track testing for the simulated work zone scenarios. And in phase three, we're going to go ahead and do the testing in the live on-road environment. Right? So those are the 3 phases we're going to go. And the way we do it is, it's very similar, very simple. We will set up the work zone, and we will map the work zone, and we'll process and upload the map into the vehicle, and we'll conduct the simulation. And then once that is done, we will move on to the next phase of the track testing. Right? And for this, we are going to use the CMU, which is one of our project partners. They have their own level 4 CAV vehicle. So we are going to use that vehicle for the closed track testing and the live on-road testing. And what we're envisioning is that the Penn State, who is another project partner, has another vehicle which can map the work zones, right? So that vehicle is going to map the work zones and upload that information into your map database. And then that map database will either upload the map of the CMU vehicle. It could either come from the update map, the map database, or in real time, we could see if we could upload the map through the DSRC or CV2X connectivity. So those are the 2 ways in which the vehicle can get the mapping, right? If it's a long-term work zone setup, then maybe it could get from the map database. But if it's a short-term, you need to make it in real time, then we might go through the CV2X and DSRC route. So in that, so the next question comes up, okay. What how many work zone scenarios are we going to consider, and what are the different subsets we need to consider, right? I talked about 3-legged stool of connectivity, coding, and mapping. So do we need to do all these 3 to improve the operations, to achieve the non-par, to achieve the par with the human drivers? Or can we just get away with just the connectivity, or coding or mapping, or a combination of connectivity, coding, or mapping, right? So what do we need to do so that we can have that AVs operating safely in a work zone on par with a non-distracted driver? And obviously, we need to look into both daytime and nighttime scenarios. Now, for all those who have worked in work zones in Pennsylvania, we use a term called PATA, P-A-T-A, as a quiz question to all the participants to see some chat going here. Can anyone tell me what that PATA stand for? I'm going to see, if there are any responses. If not, I'm going to tell at the end of a couple of slides. So there are, we could look at n number of work zones. If you look at around the country, there are hundreds of work zones, if not thousands of work zones, typical work zones. So what we did is we looked into PennDOT and see what are the top 20% or where do we have, even though we have many work zones, are there some typical work zones that we could use, which are like implemented 80-90% of the time. So we worked with PennDOT to come up with the 17 scenarios in different categories like short term, long term, mobile, in freeways or expressways, whatever it is, right? So we came up with 17 and we determined that, if AVs can work in 17, we wanted to see how the AVs will operate in the 17 work zone scenarios. And as you could see, we are mapping, for all the 17 scenarios. Are we going to do simulation? We are going to do simulation for almost all the scenarios and also close to course testing for all the scenarios. But because of the safety, we are going to just do 3 scenarios for the on-road testing, for the live on-road testing. We want to make sure that, when we are doing this as a research project, we want to make sure we are doing it in a safe manner. So that's why we went with only 3 live on-road testing scenarios. So with that, let me go back and check if there are any chat. I cannot see the window. So is there any answers for that? Mahmood, if you see any answers for the PATA question, let me know as I move on to the next slide.
Nothing yet, Vijay.
Okay, then I got to reveal the answer. Well, PATA stands for Pennsylvania Typical Applications. And I did not know that either before, unless I talked to some PennDOT folks and they told me what it is.
Oh, Vijay, I'm sorry. Someone actually had answered that in the Q&A. So
Oh,
very nicely done.
nicely done. Congratulations. I'm glad someone got it. All right, so we looked at the 3 goals of ADS grant, right? The one being safety, the second being data, and third being collaboration. So we talked about a lot about safety, but now USDOT want to emphasize on data sharing, data collection, data gathering, and data collection sharing as part of this grant. So we came up with a comprehensive data management system so that we could collect the data in real time and disseminate the data in near real time, which could be used by researchers and USDOT so that they could get the raw data from the testing and they could conduct further research using their own resources. Right? So this depicts what kind of data management systems we have. A system we are proposing. We have 3 environments: simulation environment, the on-road testing environment, and the closed track testing environment. All the data will be fed into this data management system, which could be consumed by the third party, by USDOT and the other researchers. The third objective of the ADS grant being ensuring that we work with multiple project partners, and which made a lot of sense due to the research nature of the project. We put together a good team with a lot of public agencies, private agencies, and local governments, so that we could do this in the right way. So this project is led by PennDOT, who was awarded the grant, and PennDOT is supported by CMU and PSU, who are academic, and Turnpike, which is the public agency. Then PPG and Qualcomm are vendors of paint. And then we have HNTB, Michael Baker, Deloitte, and Drive, who are all consultants helping to see this through. In addition to that, we also have a community of support. These are the people who supported the project while we went after the grant and who we will use to guide us through the project. So with that, what are the next steps? As I mentioned, we literally kickstarted this project in March of this year, last month. And on the very first year, we will be conducting planning and systems engineering. And in year 2 and 3, which is the bulk of what we do, it's going to be for deployment and testing. And then, mid to late 3rd year and the 4th year, we will be evaluating how our testing went. And it's a 4-year project, so we anticipate it'll be completed into 2025. So you will hear in Pennsylvania, you will hear more about it as we move on, as we move the project along. So with that, if you have any questions about the project, you could reach out to Mark Kopko, who is the project lead for this project, and I am the project manager. So with that, thank you for your time listening to the presentations.
Vijay, thank you very much. And again, thank you to all our panelists today, all our speakers today. We do have some time remaining here for some question and answers. I know a few questions have come in prior to and during this, but I'd encourage everyone, if you have any questions for any of our speakers today, please continue to use the Q&A function in this, and we will make sure that those questions do get asked. In the meantime, do want to maybe start with a couple of questions. I guess first starting off, question for April. What are the benefits of having a regional data platform, and how is it managed?
Yeah, so one of the benefits for our region is, we have a lot of partner agencies and a lot of vendors, third parties, whatever you want to call them, approach us to share our data. And so the advantage for us is having one API for the region. And so, that third party can reach out to us and, they reach a whole lot of people versus just one agency and approaching one agency at a time. So that's been our region's approach for a very long time as far as data sharing, and just like, formatting is an issue, consistent formatting, and just like our ultimate goal of getting this just transportation data out there for ingestion. So, and was there a second part to the question?
Just generally, how is it managed?
So we do have, I mentioned in the presentation that we have the Aztec partnership. It is obviously volunteers and overseen by ADOT and McDOT. We do spearhead that together. Those two agencies usually do the bulk of the work as far as management of the data. A lot of the projects, the grants, applications and writing and whatnot as far as that.
Okay, great, thank you. Are there, this is a question for, the next question is for Mike, Dr. Mullenauer. Are there any plans to leverage V2X technologies to protect workers from being hit by vehicles?
Yeah, I mean, I think I shared some examples of that. We are constantly both developing and also testing commercial products that do these types of things. And I think the big challenge here is not necessarily the production of the device itself. It's how to afford and how to manage and operationalize their use. Right? You have to put it into the procedures. You have to figure out how to standardize so that you get a good standard quality data package coming from that, and you have to figure out how to afford it as well, because it does cost money to collect and move data around. So absolutely.
Okay, great. Thank you, Dr. Mullenauer. Next question is for Vijay. What specific changes are needed to current Workzone artifacts, things like cones, barriers, or other channelizing devices to accommodate the shift in technology?
So we are investigating two different things, right? One is with regards to the Workzone artifacts. The one is coding. If we use different kinds of codings, is it going to improve the visibility? And the second thing is connectivity, which could be VTTIs, connected cones, and connected vests, right? So if through our research we find out that those two indeed improve the AV operations, then in the future work zones, I anticipate that the cones and drums will have those special coatings and connectivity devices on them. So those are the changes I think it will happen if the results from the research comes through.
Great, Vijay, thank you. Just a quick reminder for everybody attending today. We are taking questions in the Q&A function. If you do have another question, please feel free to enter them in. In the meantime, a question for you, Todd. the work zone data exchange is obviously a pretty important aspect for connecting vehicles or connecting work zones and so and that type of thing. How do you see kind of the advancements in the automated vehicle world kind of affecting or being incorporated into the work that you're doing with the data exchange?
That's a great question, Mahmood. And I think there's a couple areas in which we could take that. The one aspect of how the work zone data exchange serves automated vehicles in work zones is obviously providing some measure of redundancy to onboard detection systems that are designed to self-navigate through work zones, which, as we're well aware, is a capability that's already on the ground to varying extents in current OEM products. But having some having the notification about specific events available as a complement to the base map provides that necessary advanced notification. Go back to Arizona's example where they talk about those areas of influence approaching a work zone. You have the inform, then the I forget the exact vernacular, but it was there was inform, awareness, and then you're right on top of the work zone. If you're waiting until an onboard system sees signs and pavement markings, you're not giving that system much time to react, or the human driver any time to make decisions in response to upcoming work zones. To take a different thought on how the introduction of ADS and automated vehicles can work with the work zone data exchange is the notion of those onboard systems providing crowdsource observations of a sort to inform the development and refinement of work zone event data as it's defined. So, if a work zone site is mapped initially with something like the work zone building tool that Mike was talking about, successive runs with automated vehicles, properly equipped or just connected vehicles, can refine that. And as ADS penetration, as vehicles with that type of observational capability increase market penetration, they can provide those necessary feedback loops that inform enhanced data quality. If a sign falls over or a cone gets moved or somebody shifts a pavement marking or something, those type of micro changes to a work zone site are hard for a human to pick up, or it would be laborious to keep data updated manually. But it's that's something that just an automated process is well suited for. Just a couple thoughts on that. That's a good question.
Yeah, Todd, thank you for that. It's certainly fascinating how the worlds are combining and colliding and working together. I do want to quickly introduce Jeff Bergsten. He's one of the folks behind the scenes helping pull this event off. Jeff has been monitoring the Q&A session, and I think he's got a couple questions for the panelists.
Sure. I think this first one is directed towards Mike, but it's are there any initial thoughts on the added costs to operate the smart vest technology? No definitive answers required, just some thoughts about costs.
Yeah. So additional, yeah, I would say, we're envisioning a solar, sort of powered RSU base station. So getting power there, I think that sort of manages that. We are, with the commercialization of that product, we're looking at making it so that it's transferable from one component of PPE to another. So if you think about winter gear versus summer gear, it needs to be something that can be removed and then reattached, I guess, to other versions of that same protective equipment. You need, if you're going to connect it to a cloud data system, you'll need a 4G modem and an ability to transfer data to that cloud. And then I guess you need something, unless you're just broadcasting it from the work zone, you're going to need some kind of a central data exchange. And again, we have that because we have a test bed environment, but maybe there are places where that would not be available, and you have to think about how you're going to serve that data up to third parties. So those are the things that I can think of straight away.
Okay, thank you. And we've got a couple more, Mahmood, if you want to just go through those or go through the ones that you had.
Sure, Jeff. The next question that we had was, bear with me, I'm scrolling through it right now to get to the top of that question. And this is a question from Jake Beers, and I think this is probably directed to Todd, but this could be directed to others as well. So just to follow up with my previous question, with so much data coming in, what are some of the smoothing and aggregation processes being considered to make test data applicable for varying situations that exist in the field?
All right, you want me to take first crack at that?
Yeah, this sounds like a multi-person answer, so we'll go for it.
I guess that gets to the the discussion of data quality and data harmonization. That's core element of the Workzone data exchange process. The overarching thing that I think is the principle for us is what is the best process to ensure that information about Workzone events that might crop up in a Workzone data exchange feed or something like that. It's important that it be, the data quality is a huge concern, and what we mean by data quality in this context is several things. It's timeliness. It's is the data comprehensive? Are we covering all the work zones? Is it accurate? Is it comprehensive in terms of how fully it describes the work zone and the changes to the operational, the local operational scheme? And finally, is it authoritative? Is it coming from a source that's vetted? It's one thing to have good data, but is it coming with the guarantee that it's valid? I mean, is it coming with that assurance that it's been quality checked? And how do we determine that? So, not a direct answer to the question necessarily, but I think those are some of the key concerns that get raised in that discussion, and it's we're still kind of working through that. But I'll leave it to others to add on.
Sounds like you may have covered it fairly well. Go ahead, Adam.
Yeah, I mean, I'll just really briefly. I mean, so the way I kind of see it is these systems talk together to kind of verify that it's that factor of safety, or so if or there is something that's not transmitting or is wrong on the transmitting data side, hopefully the car itself can interpret that and make a decision based on what it's seeing and the data it's getting, and vice versa. So if the car or something wrong with the car and what we're picking up in the field, so I don't see them I don't see the operation ever being reliant on one data source. So I think that'll kind of, especially when we cover the errors in data that can be expected from field devices.
Adam, thank you. I'm going to actually kind of keep you queued up for our last question. I think you might be, you and April might be the good first responses on this one. Given that configurations of non-temporary work zones change from day to day or hour to hour, what efforts are being made to provide training or awareness to field workers on these technologies or initiatives to generate buy-in and effective use?
So this is great. I mean, this is literally a question that is coming up right now within ADOT. We're working with maintenance and construction staff to develop our work zone data feed, and their biggest concern is, hey, the data is only as good that they're entering into the system when they enter it. So how do we keep up with the changing dynamic of a work zone? And the way I see it is that's, goes back to what we just said, the devices itself will do that. You'll blanket a 10-mile area as a work zone and maybe define nights as lane closures. And then as the systems get deployed, they're kind of sending the data back into your system, which is then correlating and then to the project, and then transmitting the more accurate, more updated information. Now, the question mentioned training. So right now, at least, it's kind of ad hoc. I imagine as these become more standardized, that there will be more training done. Right now, we do a real basic overview whenever a smart zone is deployed for the field and with that office. And I guess the concern right now is that we're kind of in this transition period where we have a lot of things going on that, seem like a monumental task to the normal construction workers or construction engineer. And I just see it, the devices and maybe some sort of, right now we have applications where we can drive the job or have a camera that picks up different things. And so these will just become more embedded in the things that they do, so they won't really have to do anything. It's great that they understand how they work, but right now we have connected message boards and they don't really need to know how it works. They just need to make sure it's deployed in the proper manner and safe according to the plan. So I don't know if that totally answers your question. April, did you want to add anything?
Yeah, I just want to echo what Adam said. McDotta is doing a very similar thing. A lot of our efforts are ad hoc. We've had honestly, very few deployments of smart work zones. So we're still kind of learning as we go and figuring out what works and what doesn't. But as far as like the training and awareness, a big part of our push is coming up from our director head. And so, with that in mind, the idea gets pushed down. And as we start projects and stuff, like Adam was saying, we have a lot of conversations as far as smart work zones and expectations, but I agree with Adam that, we don't get into how the technology really works because they don't need to know those parts, but just to know that it is here, it is available, these are the goals with it, and this is what we're trying to achieve.
Great. Well, with that, thank you, Adam and April, for that response. And thank you to all of our panelists for the engaging content and the thoughtful answers to the questions. Thank you to everyone who did provide a question. We appreciate it. After we do end the webinar, everybody should be receiving Professional Development Hour certification. So PDH is from Chad Martin from Maysite. The next webinar will be held the week of June 7th on multimodal and transit from 2 to 3:30. We do have a great list of speakers and topics for all our webinars coming up through October. Please check the AV Summit website, paavsummit.org, for those updates. Those will be up to date. And we hope to see you again at our future events. Thank you all and have a great rest of your day. Take care.
Thank you.
Kevin, are we no longer